Semiconductors, the critical components embedded in an array of technologies, from smartphones to advanced military systems, have taken center stage in the global economy. These tiny devices form the bedrock of our digital world, their significance going beyond their technological applications to extend to economic and national security. In the semiconductor industry's current landscape, Asia, with China and Taiwan at the forefront, holds the reins of manufacturing. Simultaneously, the United States has cemented its position in design and innovation, demonstrating unparalleled prowess in developing advanced chips. Yet manufacturing, the physical creation of these chips, is a capability that the US has progressively outsourced over the decades. The evolving dynamics between China and the US in this sector have given rise to what many refer to as the chip war, a competition laden with geopolitical and economic implications. This mounting rivalry underscores the strategic value of semiconductors, as nations recognize their potential to shape the balance of global tech power. America's endeavor to re-establish its position in semiconductor manufacturing isn't just an economic decision. It represents a strategic pivot, a comprehensive national initiative designed to reclaim a share of the global chip-making pie. This undertaking presents a complex challenge with long-term ramifications on the nation's technological leadership. In the quest for revival, the stakes are high, with America's place in the global tech hierarchy hanging in the balance. In a strategic move to reinforce its semiconductor industry, the United States government recently enacted the CHIPS Act, more formally known as the Creating Helpful Incentives to Produce Semiconductors Act. At its core, this legislation aims to stimulate domestic semiconductor manufacturing, research and development through substantial financial backing. The act is designed to inject a significant $50 billion into these crucial areas over the next 5 years. The CHIPS Act is a cornerstone of America's plan to reverse the decades-long offshoring trend in chip manufacturing. By providing hefty incentives, the act seeks to attract and retain semiconductor companies on American soil, thereby invigorating the domestic chip-making ecosystem. Under this initiative, the American semiconductor industry is projected to see significant growth and development. Expectations include the emergence of more advanced fabrication plants, a surge in the domestic production of semiconductors, and increased employment in this high-tech sector. This national endeavor to bring chipmaking back to American shores not only aims to restore the nation's self-reliance in critical technology, but also signals an ambitious step towards reclaiming America's leading role in the global semiconductor supply chain. The growing skills gap in the semiconductor industry represents a critical obstacle for America's ambitions in chip manufacturing. According to an estimate by the Semiconductor Industry Association, there could be a deficiency of about 67,000 skilled workers, including technicians, computer scientists, and engineers, specific to America's chip sector by the end of this decade. This number becomes even more stark when considering the wider economy, which is projected to face a shortage of approximately 1.4 million such professionals. This looming shortage is especially troubling when compared with the current academic output in relevant fields. Each year, the United States produces approximately 70,000 students who complete undergraduate degrees in engineering. This figure is significantly short of the projected need in the semiconductor industry, pointing to a wide chasm between supply and demand for trained professionals in this sector. The implications of this skills gap are far-reaching, potentially affecting both the productivity and the cost efficiency of the semiconductor industry. The absence of sufficient skilled labor could stymie efforts to run semiconductor foundries at full capacity, creating labor bottlenecks that hinder productivity. The scarcity of such professionals may also inflate labor costs, as companies compete to attract and retain the limited pool of skilled workers. This gap also has implications for innovation in the sector. A deficiency in skilled engineers and technicians could slow the development of new technologies and impede the industry's ability to keep pace with rapid advancements in chip design and manufacturing. There's a risk, too, for the wider American economy. The semiconductor industry is a key driver of technological progress and economic growth. If the industry is unable to grow due to a lack of skilled labor, this could have knock-on effects on other sectors and potentially dampen America's overall economic performance. To successfully execute the vision of the CHIPS Act and restore America's prominence in semiconductor manufacturing, this skills gap must be addressed proactively. Bridging this gap will not just require short-term solutions, but a long-term, concerted effort that combines education, training, immigration reform, and potentially even a cultural shift to elevate the prestige and attractiveness of careers in semiconductor manufacturing. The Taiwanese semiconductor manufacturing company, TSMC, the world's largest chipmaker, provides a compelling case study in the challenge of re-establishing American semiconductor manufacturing. TSMC has announced ambitious plans to pour $40 billion into constructing 2 advanced factories in Phoenix, Arizona, a move that stands to significantly bolster America's capacity to produce cutting-edge semiconductors. However, these aspirations have recently met a significant hurdle. TSMC was poised to begin production at the first of these factories next year, but the project encountered unforeseen workforce constraints. The company announced in July that it would postpone the launch date to 2025, citing the lack of sufficient workers with the necessary expertise to install high-tech equipment in such advanced facilities. TSMC's response to this setback underscores the challenges at hand. To compensate for the shortage of domestic expertise, the company plans to send technicians from its home base in Taiwan to train its American workforce. This strategy reflects an urgent need for skills development within the American semiconductor labor force and shows the industry's willingness to invest in education and training to meet this demand. The trajectory of TSMC's ambitious project has implications beyond the company itself. Its success or failure could set the tone for America's potential in reclaiming a position at the forefront of chip manufacturing. If TSMC successfully navigates the challenges it currently faces, it could serve as a blueprint for other companies looking to revive their manufacturing operations on American soil. Conversely, continued delays or setbacks could stoke concerns about the feasibility of the U.S. reclaiming its standing as a global semiconductor manufacturing leader. With the drive to establish new semiconductor fabrication plants, or fabs, there is a pressing need for construction workers skilled in the specific requirements of these facilities. The Commerce Department estimates a need for about 100,000 builders during the initial phase of investments into these highly specialized plants. Constructing fabs isn't a standard building task. It requires specialized knowledge due to the intricate and complex nature of these high-tech manufacturing sites. Their design needs to accommodate specific air quality controls, vibration dampening, and temperature and humidity consistency, among other specialized criteria. As a result, not just any construction workforce can be rallied to meet this demand. The situation calls for a large-scale recruitment and training effort that could equip construction workers with the specialized skills and knowledge necessary for the task. To address this daunting challenge, the U.S. government is stepping in with a carrot-and-stick approach. As part of the CHIPS Act provisions, the government is offering substantial subsidies to companies venturing into semiconductor manufacturing. However, there's a catch. These subsidies are contingent on the companies outlining clear plans to recruit and train the necessary workforce, specifically those needed to construct these fabs. This linkage of financial incentives to comprehensive workforce development strategies places a significant responsibility on the companies. They must now invest in creating effective recruitment campaigns, developing detailed training curriculums, and implementing these plans in a timely manner. This approach reflects a strategic move by the government, using policy to encourage private sector investment in workforce development. If successful, this could result in a substantial boost to the construction sector, particularly in terms of specialized construction labor, helping bridge the immediate skills gap while also laying the physical groundwork for America's resurgence in the semiconductor industry. However, the government's plan isn't a silver bullet. The question remains whether companies can successfully attract a sufficient number of workers into the sector, given the intense competition for skilled labor in other high-tech industries. The training programs must also be effective and expedient to meet the pressing timeline for fab construction. The immediate future of America's semiconductor industry rests heavily on these factors. The second critical aspect of reviving America's semiconductor manufacturing lies in the necessity of highly skilled technicians and engineers. Technicians are tasked with vital duties in fabs, including inspecting tools and products, troubleshooting, and performing critical maintenance. Traditionally, these roles have demanded at least 2 years of specialized training at a community college or vocational school. However, the current pressing demand is driving innovation in training programs. For example, some educational institutions have started to experiment with much shorter courses. The most striking are quick start programs, like those offered by Maricopa Corporate College in Arizona and Portland Community College in Oregon, which promise to produce technicians in as little as 10 days. While these short-term courses are unlikely to equip students to handle multi-million-dollar machinery right away, they are designed to introduce individuals to the industry and stir interest in pursuing a career in semiconductors. These rapid training courses serve as a gateway, enabling a fast-track introduction to the field and paving the way for further education and training. Parallel to these training initiatives, universities have a significant role to play in developing a high-tech workforce for the semiconductor industry. Notably, universities located near major fab construction sites, including Arizona State and Ohio State, have expanded their offerings of semiconductor courses as part of engineering and physical science degrees. This is an important step in aligning educational institutions with the industry's needs, developing programs that offer students direct insight into the field. Leading the pack is Purdue University in Indiana. Last year, Purdue launched a semiconductor degree program catering to both undergraduates and graduates. This lab-to-fab model aims to closely collaborate with companies, providing students with hands-on experience under conditions they'd encounter in the industry. Purdue has also leveraged industry partnerships to offer substantial stipends to students, fostering early interest and engagement with the semiconductor sector. These educational and training innovations are essential components of the drive to upgrade America's semiconductor workforce. By streamlining the path from education to industry, these programs aim to meet the rapidly increasing demand for highly skilled workers in the sector. However, their effectiveness will be measured by the quality of their graduates and the speed at which they can fill the significant skills gap. America's semiconductor industry has historically also relied heavily on immigrant talent. Immigrants represent approximately 40% of the highly skilled workforce in the sector. They bring in diverse perspectives, rich expertise, and an immense contribution to the industry's innovation and productivity. However, this vital resource is becoming increasingly limited due to strict caps on visa programs. The H-1B visa, for example, is often used to bring highly skilled immigrants into the technology sector, but the number of visas issued each year is subject to a cap. This limitation means that as the semiconductor industry expands, it becomes increasingly challenging to source international talent. The cap creates a bottleneck, constraining the growth of a sector that is already facing a significant talent shortage. Political opposition to immigration also exacerbates the problem. Proposals from certain politicians, including former President Donald Trump, have suggested limiting or even eliminating these visa programs. Such changes could further restrict the inflow of highly skilled workers to the semiconductor industry. This combination of visa restrictions and political opposition creates a risky scenario for the American semiconductor industry. Without a sufficient influx of international talent, the industry may struggle to fill its growing need for highly skilled workers. It's an issue that calls for strategic immigration policies that can balance national security concerns with the demands of a rapidly growing, globally competitive industry. Addressing the immigrant talent pool, therefore, is a critical aspect of America's strategy to revive its semiconductor manufacturing sector. Ensuring access to global talent, along with developing homegrown skills, will be key to overcoming the workforce challenges that the industry currently faces. As the United States seeks to regain its standing in the semiconductor industry, it faces a formidable set of challenges. Addressing the skills gap, creating advanced manufacturing facilities, and navigating the complexities of reshoring a vital industry are significant hurdles that need to be surmounted. However, these challenges also represent opportunities to revitalize American manufacturing, stimulate economic growth, and improve national security. Successful implementation of initiatives like the CHIPS Act could potentially reverse decades-long trends, bringing manufacturing jobs back to American soil and establishing the country as a global leader not only in chip design, but also in production. This could also spur innovations, as closer collaboration between design and manufacturing teams could lead to the creation of more advanced and efficient chips. However, the stakes are high. Failure could mean continued reliance on foreign manufacturers, leaving the country vulnerable to supply chain disruptions and geopolitical tensions. It could also lead to missed opportunities in terms of jobs, economic growth, and technological leadership. In essence, America's attempt to reclaim its position in semiconductor manufacturing is not just a matter of industry competitiveness. It is an endeavor with far-reaching implications for the nation's economy, security, and role in shaping the future of global technology.